You need to keep an eye on set, guys. You might not even just like, oh, well. You know what I'm gonna throw it out. You won't honestly leave a wonder. That's straight around.
Who didn't get their test yesterday? I got it. All right. Hey, I didn't get to make too many comments about the test that I handed back. I'm just going to say this. As a class, we did okay. I'm just going to point out the obvious for some of you. Hey, was the test different or the same as the practice test?
Different.
It was the same, right? So for those of you that missed stuff, I mean, I'm not talking about, oh, you added 2 and 3 and you made a mistake. No, I'm saying that like there's a couple you had on your paper. I don't know what to do here. How is that possible that you didn't know what to do? It was the same as the practice. I'm not saying that you claiming you didn't know what to do. Wait, did I say that right? I'm not claiming that you were confused, right? You certainly were confused. But when I hand you the practice test and I don't get like red flags, like I don't know how to do this, right? It's the day before the test. Not a single one of you that had on your test, I don't know how to do these, came up to me and said, I don't know how to do these. So my belief is that when I give you a practice test and no one questions like how to do this, then we're okay. Right? If that's not the case, then you're in high school. You're not in 7th grade, right? You're a sophomore in high school at that. And you got to come up to me and say, Mr. G, I don't know how to do these. Like I'm lost, confused. I can help you the day before the test. I can't help you on the day of the test. It really saddens me when I see someone on the test like IDK, I don't know, I'm confused on how to do this, because when I hand you a practice test that is literally the same question, I just change the numbers slightly, right? And it's like you're failing the test and you're giving away 3 points. So don't let that happen to you. All right, any questions on the homework? 120. Number 11? All right, take a look at that. Number 11, you've got this, well, we don't know what the shape is yet. It's a parallelogram, but we don't know that. So you have this shape, we'll learn it next chapter, and you have a diagonal. We have had the definition of diagonal, though, and then it goes 1, 2, 4, 3. So 1, 2, 4, 3. Then there's just a whole bunch of questions about this. All right, so it says, do you see 2 triangles in there, Wes? Yeah. And it says that the 2 triangles are congruent. So it says that P-A-R-L, P-A-R-L. Okay, so here's what you got to do with your mind. This is a hard one, right? How do those 2 triangles, given their angles, match up? If I take the bottom one and I flip it completely over, does it match up with the top one? Right, so I'm going to draw the bottom one. This is the bottom one, just all by itself. Right, how do you get this to match this? What would you have to do? Okay. If we flip it like this, right, let me see if I can draw that. I would get that, and I would get that, and I would get that. That's what it would look like if it flipped.
I mean, like,
rotate it?
Yeah.
Okay, yeah. If I flip or rotate this, I'm using the wrong words. If I rotate this 180 degrees, then it matches up to that. So whatever this is would match up with this, so that we can see that what A and L match up, and then what R and P match up, and that's all we need, right? We can get the rest of it from there. So let's see. It tells us that triangle. This is question number A. So it says PAL. PAL, that would match with, let's see, P goes with R, A goes with L, P goes with R, and then what letter am I missing on the second triangle? I'm missing an A, so RLA. Yes?
Yeah.
Easy or hard question? This is more medium type thing, because you got to be able to flip that sucker around with your brain, right? you know, even maybe, I don't know, even taking your book and flipping it over and asking yourself, is that the way it's supposed to look? Maybe that might help as well too. Okay. Once this is done, so here's your congruency statement. Is the rest easy? If you have the congruency statement,
Yeah.
I don't need to look at the picture anymore. I just look at that right there. The next question says PA. Well, clearly that goes with RL, and that's the rest of the rest. Okay. Question C, though, says that angle 1 is congruent to angle, well, angle 1 is here. That would be angle A, and A goes with L, so the 1 would go with 3, right? But the question is why? Well, why? Because of, well, congruent parts of congruent triangles are congruent, CP, CTC. So maybe the because part was a little confusing. You could get the PA is parallel to LR. Why? Because way back in chapter 2, right? Or sorry, chapter 3, we know that if alternate interior angles are congruent, then the two lines are parallel. And then D is just a repeat of C. So 2 goes with 4 because CP, CTC. And then they're asking you to write another statement. So one of the ways of writing D would be PL is parallel to AR. You could have said LP is parallel to RA. Once again, because alternate interior angles are congruent. Okay, that was 11. Anybody? Anyone else? Okay. I'm just going to collect this. Well, actually, no, I'll call them out real quick. Just the even ones. Just the even ones. All right, number 2 is the measure of angle 1. Just remember, if it has M angle, you got to put your answer as M angle. Number 4 is segment IG. Number 6 is triangle BGI. Number 8 is definition of congruent triangles or congruent polygons or congruent figures. Any of those will work. Number 10, A is triangle KRO. B is angle K because of CP-CTC. C is segment KO because of CP-CTC. Then point O is the midpoint of segment SK, that's C. And D is angle R because of CP-CTC. And there's a second part because alternate interior angles are congruent. 10 and 11 were the hardest ones. Absolutely. And I gave you what, through 13? All right, so 12 and 14 you had to graph. That's what the graph paper was for. So let's see, I'm searching. Where is the answer to number 12? Where are you? See the answer. Oh,
The answer is
there we go. The answer is 7, 2. 7, 2. That's it. Okay. Who ordered all the smoke?
Yeah, oh.
Oregon Gate. What? All right, really important day. Unfortunately, I got a bunch of absences. Oh, this is going to be not for you guys. You guys are going to be fine, but the people that are absent, they're going to have to absolutely. Missing a geometry class can be very bad in the sense of, I'm not saying, oh, come to school sick, but I'm just saying if you miss, right, you really probably need to go on Teams and watch the video rather than try to figure it out yourself. If you got somebody in your family that's really good at math and geometry, absolutely, they can teach it to you. If you're really good at geometry, you can certainly probably teach it to yourself as well, too. You might have to ask a few questions, but if you miss a class, right, and you just try to roll with it, some bad things could probably happen. We're going to do 2 days of this. So you guys, thank you. So you guys are going to get the class, and then tomorrow we'll do a practice day. So you guys will be solid, I mean, rock solid on this stuff. People that missed a day, if they don't read up on this, they're going to be completely, totally lost. If there wasn't one of the more important classes of the year, today is that class. Here we go. Yes? All right, so proving triangles are congruent. Proving triangles are congruent. No, we're not going to, we'll do one proof, but proving triangles are congruent. All right, so last class we talked about, and this is already in your book of truth. We said that polygons are congruent if and only if we can match up their vertices and their sides so that all the parts are congruent, meaning all the angles, the corresponding angles are congruent, and all the corresponding sides are congruent. Okay, so we got this basic definition. This is an if and only if statement, so it goes both ways. If the two polygons are congruent, then all their corresponding parts are congruent. And then this part first, this part second. So if the corresponding parts are congruent, then the two triangles are congruent. Okay? Today, this chapter, and the rest of the book, you're going to be doing this one thing nearly every single day. And that's this. Are the two triangles congruent? Yes or no? And oh, by the way, it's going to be yes. Today we'll get a couple no's, but most of the time it's always going to be yes. I think like 99% of the time, the two triangles are going to be congruent, but you got to prove that they are congruent. So today's class is learning the techniques of showing that two triangles are congruent. All right, so I'm going to give you one triangle. I'm going to give you another triangle. You're going to prove that the two are exactly the same. They're congruent, right? Question is, well, how do you do this, right? Method number one, which we will never use, ever, but it is a method. Well, how do we prove that two triangles are congruent? Somebody? What are we going to do, Les? No, we're not going to mess with the exterior angles, although we could.
Just write out the three vertices, set a congruent to the other three vertices.
Okay, if I just show it for the vertices, is that good enough? This is called method one. Well, what are the parts of a triangle? From yesterday. What are the parts of the triangle? There's two parts, main parts of a triangle. What are the two main parts? The sides and the angles. So method number one is I got to show that all three sides of one triangle are congruent to all three sides of the second triangle. And then I'm not done. Then I got to show that all three angles of one triangle are congruent to all three angles of the second one. All right, this is called method number one. I got to show that all their corresponding parts are congruent. So how many things do I need to do? I just told you the things. How many of those are we got to do? Count. Somebody count.
6.
There's 6 things I need to do to show that these two triangles are congruent. I got to do 6 things. Sound like fun?
No.
Right? It's not. Yet that's the only technique that we have so far, unless we can come up with some shortcuts. Today's class is on. It's on the shortcuts. Is it going to be one of those classes, guys? Right? No, I'm saying, is it going to be one of those classes where I just stop and pause and nobody says anything? Come on. Stay with me. Engage in the class. All right. So method number one, we're not going to do this, by the way, is that you got to show that all three angles of that triangle, the blue one, are congruent to all three angles of the green one. That's 3 things to do. Then you got to show that, you got to show that all 3 sides of the blue one are congruent to all 3 sides of the green one. That's 6 things you would need to do. You can do this, but it turns out there's some shortcuts. So today's about the shortcuts. All right, so think about this. Do you see that triangle right there? Now you got to turn your brains on. You got to look. Ready? I'm waiting.
Yeah, sure.
Right? That means eyes are on the board. You're looking. Okay. So if I have this triangle and I draw another triangle, and let's just say that this triangle has the same length as the bottom, and it has the same length as this one right here. Right? So that means that I've got 1, 2, 3, and 1, 2, and 1. You see that part? The third side, I'm going to have it floating over here, is that long. It's sitting right there. Is there any way of fitting this piece onto those 2 pieces? Now I'm going to allow you to move this piece left and right as much as you want, but it's got to stay attached right there. So I can move it like this. But I got to attach this piece to this end and that end. You see the game? Is there any way to attach that so it won't look like this? So this is this long right here. I'm going to attach this end to this part, and I can move this as much as I want, and I can move this one as much as I want. Is there any way to connect this piece to the two ends and it not look like this? Therefore are the two triangles congruent. Did I ever talk about angles when I did this? The only thing I talked about was side measurements, right? So I showed that the three sides of this triangle are congruent to the three eyeballs on the board. Come on. If the eyeballs aren't on the board, you're not paying attention. I just showed that the three sides of this triangle are the same as the three sides of the, they're different. Obviously, one is not the same as two, right? Three sides of this triangle are the same as this one, and I just showed that the two triangles are congruent. This has a name. Take a guess. This is called the side postulate. Now, technically, we sort of kind of proved it, but we call it a postulate. It's accepted as truth. So in your book of truth, oh, this also works with tick marks, and it works with numbers. Is this triangle the same as that triangle? Right? And I just put numbers instead of tick marks. Either way, numbers or tick marks. So write this down. This is called the SSS postulate. You will remember it as simply SSS. But what it says is this in words. If three sides of one triangle are congruent to three sides of another, then the two triangles are congruent. This is our first shortcut. We never said anything about the angles. I never said, yeah, three sides in one of the angles or three sides in two of the angles. I just said if three sides of one triangle are congruent to three sides of another, then they're congruent. This does not apply to all polygons. This applies to triangles. It is possible to make a pentagon not congruent to another pentagon if all the sides are congruent. You can make it concave, and it wouldn't be congruent to a convex one. Okay, first shortcut, SSS. If you want to show that one triangle is congruent to another one, well, then now you got a second tool in your box, the SSS. We're never going to use the first one. We'll call it method one. It's not even talked about in the book. Nobody wants to show that all three sides and all three angles are congruent. It's just too much work. Hey, shortcut, just show me the three sides and you're done. Remember, the goal here is to show that the two triangles are the same. They're congruent. Okay? So show me that all three sides are the same and you're done. Okay, easy or hard to do? It says 3, 4, 5. It says 3, 4, 5. You're done. All right? If you see that three sides of one are the same as the other one, you can claim the two triangles are congruent by sides outside. The consequence of that is, hey, what can you tell me about angle E and angle Y now? If you have SSS, what can you tell me about angle E and angle Y now? They're congruent. We never even talked about the angles. That's kind of the power of this. Okay? All right, so the first shortcut method is called side, side, side. We do not have an angle, angle, angle postulate. You would think that we do, right? Anybody know why? 60, 60, 60, equilateral or equal angular. Guess what this one is? This one also is 66. Are these two triangles congruent? That's why we don't have an angle, 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 right? It can happen with a side, 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 just like that, but it can't. It could happen with an angle, 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 but it doesn't have to happen with an angle, angle, angle. Okay, so we do not have an angle, angle, angle. Hopefully, I didn't put that bug in your ear. All right, remember our goal here. We're going to be proving from now on the rest of the book. I'm going to give you two triangles, and you're going to be asked to prove that two triangles are congruent. All right. So far, we have, well, technically we have two techniques, but we really only have one. What's the one technique? Triple S or side, side, side.
It reminds me of the boat, like the SSS Chartier.
Okay. There are other ones. We're going to get 3 of them today. Okay. Do you remember doing this in pre-algebra? Anybody? We did this for one day. Okay. All right. Now it's going to get ugly in class, right? I'm going to give you some definitions. We're going to write these down, and it's because these definitions are used in the other 3 shortcuts, or the 2 shortcuts, sorry. There's actually 3, but we only get 2 of them today. So I apologize for these definitions. I didn't make them up, right? But we're going to use these definitions and the other 3 shortcuts. All right, so you don't need to put these in your book of truth, but you do need to write them down on the paper. All right, here we go. You see the triangle? All right, in box 1A, draw me this. It's not going to be much to write. Draw me this triangle in box 1A. I got a triangle. One of the sides is AB, the other one isn't labeled, and I got a variable C right here in this corner. So I don't know how big angle C is, so I just put C there for a variable. Chris, you drawing this? In box 1A. We're going to give a name to the angle that is, or to the side that is opposite angle C. Guess what? We're going to give a name to the side, this side right here that's opposite C. Take a guess. We're going to give a name to it and it won't be C.
AB.
It's the side that is opposite C.
What's the name?
And guess what the name's going to be? It won't be AB. That is literally the name. We're going to call it the opposite side. That's the easy one. The opposite side is the side of a triangle that is opposite a given angle. Okay, well, I gave you angle C, and the side opposite, we call it the opposite side. Not very inventive. This name I don't mind. This is a good name. Opposite side. What would be the opposite of the opposite side?
The opposite side.
Okay. We good with that? You're going to draw this triangle a couple times, by the way. And we're just doing this so that I can give you the other 2 shortcuts today. There are 3. We'll talk about the third one day after tomorrow. All right. So the side opposite angle C is called the opposite side. Easy. All right. Same picture. For this time, we'll start with the side. This one right here. We'll start with this side. Guess what we're going to call the angle that is opposite the side? Somebody?
Opposite angle.
We're going to call that the opposite angle. Okay, well, that one's easy. And then we get to the 2 hard ones. All right, so the angle that is opposite a side is called the, and remember, this is for triangles. You know, if I give you an octagon, which side is opposite? Oh, that was kind of hard, right? But for a triangle, it's easy to see what side or which angle is opposite the given either angle or side. So we would say that angle A is opposite side AB. Angle C. What did I say? Angle A? Angle C is opposite side AB. So far, so good, right? You may not know why I'm doing this. You will in a second or 2. Okay? They're just definitions. We're going to use them in our shortcuts. We okay? Now for the 2 hard ones, this will be box 2. All right. So look at the picture and let me try to explain it. Oh, now he has a C there on vertex. Okay. So what we're going to talk about is those 2 sides right there, side AC and side BC. Do you see the 2 sides I just made red? What's between them? Okay. So there's an angle between the 2 sides in red. Make sense? Guess what we call angle C? Shouldn't it be called the between angle? We don't call it the between angle, but that's what it is. It's the between angle. I didn't come up with this. I will apologize for all mathematicians. We call angle C the included angle. I don't know, maybe you got 2 friends and they're standing next to you and you're in the middle and they're giving you a hug or something. I don't know. They're including you in their little gang, right? So angle C is included between the 2 sides. It's called the included. It certainly should be, at least in my mind, called the between angle, because that would make perfect sense.
Would you take the between angle?
I'll just say that we're only going to use these words one day, or 2 days, one day, today, and then when we talk about the other shortcut. And then we won't hear these again. So that's called the included angle. What would be the opposite of this?
The opposite.
All the same pattern as box 1. Okay, so it would make sense there'd be an excluded angle. That would be angle B and angle A, but we actually don't have the excluded angle. What we're going to have is the opposite of this, right, is this. Same picture. Now I'm going to give you two angles, angle C and angle B. What's between angle C and angle B?
The included side.
The included side. So the included side is when remember this only applies to triangles. I give you two angles, and the side that's between those two angles is called the included side. All right, and like I said, the only reason for giving these four definitions is that we will use these definitions for our, at least today, our two shortcuts. There are three shortcuts. There's actually two more that we'll learn after that, but not for a while. We got to talk about right triangles. Get the other ones. Okay, so that's out of the way. We've probably forgotten what the heck we were doing in the first place, right? Because I had to give you these definitions. I've just found that if I don't give you these definitions, then when I define the other two shortcuts, they're like, what the heck is an included side? We good? All right, so back to the recap, right? The side that is opposite angle C is called the opposite side. The angle that is opposite a side is called the angle that is between two sides is called the, and the side that is between two angles is called the, you got it. All right, we're going to use all of these in the next two. All right, here we go. So what we were doing this, remember, we're trying to show that the blue triangle is the same as the green one. So far, we only have one technique, that's SSS. Right? Method number one does exist. I would have to show that all sides are congruent to all sides, all angles. It would take 6 steps. Nobody wants to do that. So we don't even talk about method number one. But we do talk about side, side, side. And now come, at least the rest of the class, the two other shortcuts. There are more, but just 2 for today. All right, so think about this. Now you got to pay attention again. You see the board? We got a triangle. We are given a side, another side, and the included angle, right? Now you see why I had to give you that definition. So we're given the included angle of 2 sides, okay? Let's try to draw another triangle the same way. If I draw another triangle, well, I'm going to start with that side, AC. Well, it's telling me I got to use that angle right there, right? So I don't know what that angle is. We'll call it, I don't know, it looks like about 70 degrees. So if I draw another 70-degree side, oh, but wait a minute, I want this bottom to be the same size, so let me make it the same size. Oh, and I want this one to be the same size, so I got to make it the same size, right? So now I have that. Is there any way to connect this to this and be longer or shorter than that side? Can you wrap your head around that conundrum? Is there any way to draw between here and here and not be exactly the same distance? Guess what we're going to call this one?
Side angle.
We are given a side, another side, and an angle, but we're going to be careful of how we arrange letters ASS, right? Right? We're going to say, instead of that, we're going to say side, angle, side. Okay? So this is called the, take a guess.
Sides.
Right? This is called the side, angle, side postulate. And we just, technically we proved it, but we don't prove postulates. Boy, that's a long definition. It says side, angle, side. It says if you have 2 sides and the included angle of one triangle, and all of that junk, the side, angle, side, is congruent to a side, angle, side of another triangle, then the 2 triangles are congruent. So once again, instead of proving 6 things, I only need to prove 3 things. 2 sides and an included angle. That's a lot of words. You need to remember side, angle, side. But it's got to be 2 sides and the included angle. You can't just have 2 sides and an angle. It has to be 2 sides and the included angle. You're going to see when we get to homework tonight, they're going to give you 2 sides and an angle. It doesn't spell SAS, it spells other things that aren't SAS. Because they're not going to give you 2 sides and the included angle. They're just going to give you 2 sides and maybe the excluded angle. So far we have SSS. That one's the easy one. You're not going to make a mistake on that one. SAS you can make a mistake on. It's got to be 2 sides and the included angle. Not just two sides and an angle, two sides and the included angle. Anyone lost? So today's an important class. You're like, well, when's it going to get hard? It doesn't. This is just an important class. It's pretty easy today. We good? And by the way, in a proof, what are you going to say? You're just going to say SAS. You're certainly not going to say that. You're not even going to remember it's a postulate. You're just going to say SAS. Okay. Are these two triangles congruent? Yes or no? Well, how do you know? Well, how do you know it's side angle side? We go to the first triangle, and let's see what they gave us. Well, they gave us two side measurements, and they gave the angle in between. So for this triangle, the top one, it is clearly SAS, right? The two sides and the included angle. Now, it's not just because it's SAS and this one is also side angle side. It's that the numbers are also the same. Hey, I got a 3 and I got a 3. Hey, I got a 9 and a 9. I got a 60 degree and a 60 degree. But you got to make sure that it is SAS. Right? If they give you this side right here is 10, right? Well, technically I got two sides and an angle. There is an S, an A, and an S. But this doesn't spell SAS. That's not the included angle. The included angle of these two sides would be this one. That would be an SAS. This spells AS, you know what, right? Doesn't spell SAS. You got to look at the picture and make sure it's the two sides and the included angle. And further, it's not that just because it says SAS, it's true, because the numbers are the same. They're going to trick you. They're going to give you numbers that are the same. It won't be an SAS. It will just be two sides and some random angle. It won't be the included angle. So yeah, we say by SAS, the two triangles are congruent. Tonight for homework, they're going to say, why are the two triangles congruent? And then they're going to ask you to write a congruency statement as well. Could you do that? Okay. All right, well, there's more. And there's more than what I will show you today as well, too. I'm only showing you 3 of them today. All right, another picture. Guess what this one's going to be called?
ASA.
Angle, side, angle is what it's going to be called. Okay, let's see if we can prove these two triangles congruent. So let's see, I start with AC. Well, that's congruent. I'm forced to draw an angle that's that. I'm forced to draw an angle that's that. So I have that's congruent to this, right? Is there any way to connect, if I extend these two, to where this side is not the same as this one, and this side is not the same? It would be possible. The only way it would be possible is if I could change the angle. Well, I can't. I'm forced to use that angle right there. I should have 2 parts here, sorry. Okay? So we get this one. This is another one. This is a third postulate. This is going to be called the, what do we got? Yeah, but use the words from the definitions. What do I have? Okay, but I have 2 angles and the definitions, 2 angles and the included side. That's what ASA is. It's 2 angles and the included side. It's not just 2 A's and an S. It's got to be 2 angles and the included side. Tonight for homework, they're going to give you 2 angles and a side. And you're going to say, oh, it's going to be ASA, and it won't be ASA. Because they don't give you the included side. Make sure you look at both triangles and that you ensure that you can see 2 angles and the included side. Two angles and the included side. That's the side between the 2 angles. That's ASA. Don't lose sight of the entire picture. The entire picture is, I'm trying to show that this triangle is the same as this triangle. We now have 3 techniques, SSS, SAS, and ASA, to show that those 2 triangles are congruent. And they're all postulates, by the way, even though I kind of proved it to you. I don't think my geometry teacher ever proved this. She just said it's postulates, and we're not going to prove it. The SSS is probably the only one that I would accept that we could all look at it and agree, oh yeah, they must be congruent. But SAS and ASA, it requires a little bit of at least thinking about it. All right, so I will certainly address the bad word of the combination of A's and S's. All right. Oh, and let me give you a quick ASA example. So here we go. ASA means two angles and the included side. So check it out. An angle, and the included side. If it had said this is 4, right? Then that would be an angle, side. We don't have that one yet. We will. We just don't have it today. Okay, so I need 2 angles and the included side. Hey, I got 2 angles and the included side. You don't stop at one triangle. You got to make sure the other triangle is also ASA. It could be SAS on the other triangle. Then the 2 triangles are not congruent. But this one is also 2 angles and the included side. And then the last part is you got to make sure the numbers match. 90, 90, 55, 55, 4, 4. So it's 2 things. Make sure that they are both either SSS, ASA, SAS. And then the second thing, make sure the numbers match. Okay? So we would say by ASA, those 2 triangles are congruent, and then they're going to ask you to write a congruency statement. Well, how do you do that? Well, once you determine that they're congruent, well, clearly 90 goes with 90, 55 goes, then the last, you only got one more angle, it's easy to see which one will match up. Okay, we good? All right, so where are we? We're proved 2 triangles are congruent, right? We're proved that the blue one is the same as the green one. We got 3 techniques, SSS, SAS, and ASA. There are more, but those are the 3 we got so far. Okay, what you don't have is this, right? You see this triangle? Okay, if I were to draw that length right here, so we'll make it the same length. If I were to make this one 30 degrees, notice I don't have any distance here, so it could be any distance. It could be any distance. This one has to be 6, right? Unfortunately, I don't have a diagram that's accurate. Imagine that's 6. So if I put it right here, well, it touches right there. Triangles are congruent. But if I move it, it could also touch right there. So how many triangles could you form if this is 6 units long? How many different triangles could you make if that one was 6? Right? If this is 6 and I put it right here, well, clearly I'm touching right there, but I could also move it and touch right there. So how many different triangles could you make? I could make 2. Therefore, this doesn't exist in congruency, right? And here's a better picture instead of mine, right? It's saying that if you make this side 6, it could touch here. It could also touch way over here. It'd be exactly a different triangle, right? Now let's see what we have. We have an angle, side, side. And this is why that doesn't exist. And that's the only joke that is in math class. And I chose not to write it, but. All right. There's your only actual joke in math class. Okay. And what was the other one we said we didn't have? So we don't have the angle side side postulate. We also don't have the. Yeah, that would be the same thing. We also I already showed it to you once. We don't have the angle. So remember, we don't have angle. We don't have angle side side. So these are the 3 that we have. Okay. There are 2 more that I will show you, but not today. Okay. Cool. So what's homework going to look like? Well, let's do a proof first. All right. We'll just do one proof. Here we go. We haven't done a proof in a while. All right, Danny. It says you got 2 triangles. Do you see the 2 triangles? Okay. What do you want to call them? Red, blue? What do you want to call them? Okay. Except we're going to call them MET and JET. MET-JET. MET and JET. Can you visually see the 2 triangles? Do they look like they're the same? Okay, unfortunately in geometry, that's not proof enough. We got to prove it. So I'm going to prove that this triangle is the same as this one. Danny, we have 3 techniques. Tell me the 3 techniques to prove that any 2 triangles are congruent. Tell me the 3 techniques that you wrote down. The first one we learned was SSS. The second one was SAS. And what was the third one? Those are the only three that can prove, at least right now, that this triangle is the same as this one. That's it. I don't know which one it is. Well, let's see if we can figure it out. All right, so I got my given, right? And I got where I'm going. I can tell you what the answer is right here. The answer is either or SSS, right? So it's either going to be, the reason for this is either going to be SSS, SAS, or ASA. Let's find out which one it is. What's the only bit of information that, or there's 2 bits of information I haven't used. What are those 2 bits of information? Say again? Well, if E is the midpoint, Danny, what does that mean? What does a midpoint mean? What does that mean? No. What does midpoint mean? You said it's in the middle, and then I repeated my question. What does it mean? What's middle mean? What does that mean? Okay, if I usually have a pencil, but I don't right now. But if I go with a pencil at the middle, what just happened? What does that mean? Good. Very good. Well done, sir. All right. I do have a pencil. I broke it in half. If I put this one next to this one, what does it mean? I probably didn't break it perfectly in half, so I'm not going to put it. But if I had broken them perfectly in half, if I put them together, what would it mean? Same or different? It would be the same. Did I make a good job? No, I didn't. Right. But let's imagine. Right, these are not the drawings you're looking for. If you break something in half, you've created 2 equal things. You buy that? Okay. So E is the middle. So what? Take that pencil thing, apply it to this. If E is the middle, if E is the middle and you cut it in half, what did I just make? Okay, help them out. What did I just make?
2 equal lines.
I made 2 equal, not lines, but 2 equal. I didn't make a triangle if I break a pencil. I made 2 equal segments.
That's what I said.
No, you didn't. You said 2 equal triangles, 2 equal lines, right?
Oh.
So which ones are now equal? Tell me. Now look at the picture. Tell me which ones are equal. Tell me which ones.
Yeah.
I broke E. E is the midpoint. So what did I just cut in half?
M and J.
Say it.
M and J.
M and J are points.
Built 2 lines.
Tell me which ones.
M, E, and E, J.
Thank you. So that's congruent to that. Yes? That's what happened because it's the midpoint. Okay. I can say that. What's the other thing I haven't used? What's the other thing I haven't used? What do we get from that? That they're perpendicular. What do we get from that? That MET is what? So this is 90 degrees. So what could I physically put on the diagram? If it's 9 degrees, what could I physically put? Okay. What else? You can do this. We're almost there, by the way. She's whispering in my ear exactly the answer. Now, the rest of you do the same thing. Don't whisper in our ear, though. If this is 90, then the other side's got to be 90. Why? There's a couple reasons. Well, how did you conclude that this side was 90? Not it's cut in half. It's cut in half because it's perpendicular. Well, if it's perpendicular, then it's got to be perpendicular on the other side as well, too. The other one would be, that's one reason. What would be the other reason that it's 90? Well, if this side is 90, how much is left over? Because it's supplementary, right? 180. Either one of those would have been fine. Okay. Now here comes the one that you're not expecting. I got a side and I got an angle. Well, I need a side. Is there any side? Well, we just used that bit of information. We just use that. There's no bits of information left. How do I show that this side is congruent? Oh, this is a tricky one. What? No. I'm gonna mess with your head here. I'm gonna take the two triangles and draw them apart from each other. You just show that that angle is congruent to this, or that side's congruent to that side. You show me that that angle is congruent to this angle. Why is this side congruent to this side? They're not parallel. Where did they come from? Where did these sides come from? No, true, but push them back together again. How was I able to split them apart in the first place? If I push them back together again, they look like this. How long is this side right here? I don't know, but give me a number.
10.
If I pull them apart, how long is this side?
10.
How long is this side?
10.
Why?
Because you pulled them part of the midpoint.
Not at the midpoint. The midpoint had nothing to do with it. They are the same side.
Oh my God.
It's literally the same side. It is physically, stop what you're doing, you've got 2 minutes. It is physically the same side. We have a thing that says that you are equal to yourself. What's that called? That is called the reflexive property. Now you got to really think, turn your brains on, listen. Eyes on the board. You're going to use this reflexive thing. Remember I said, hey, there's a reflexive thing that sounds stupid, but eventually I'll show you when you're going to use it. You're going to use it today. You're going to use it the next day. You're going to use it almost every day. So this is called reflexive. So let's finish the proof. Well, let's say we said that these two sides are congruent. Why? Why did we say? We split it in the midpoint. We said this angle are the same. Why? Perpendicular lines, basically, right? And then we said that this side is congruent to itself because it's the same thing. That's called reflexive property. Okay? Therefore, we have a side, we have an angle, we have a side. Why are the two triangles congruent? SAS. All right, I want to show you this last thing. Tonight for homework, your homework will look something like this. Let me get to this. You see the pictures? We only have 3 ways of proving triangles are congruent. What's this say? Read it. What does this say? ASA. So these two triangles are congruent because of, that one's an easy one. Read this one. What does it say? Read the top triangle. What does it say? What's that? The same side on both triangles. Reflexive property. So this one is true because of, this one's harder. We got 2 sides, but wait, that's over there and that's over. This ain't reflexive. It can't be. There's nothing, there's no marks here. Oh, if we got vertical angles, that means this is congruent to this, so this is S. Oh. All right, now here comes the tricky ones. What's this one say? What's it say? Literally, read it. You've got attention. What does this one say? What does this one say? No. What's this one say? SAS, but what does this one say? You're going to see this, you're going to see SAS, you're just going to write SAS. But you got to look at, this one says donkey as well, too. It says angle side side. Where's my donkey? And it is actually called the donkey postulate. All right, see ya.
It's not a bad word, guys. I was so confused there for a second. I'm like, wait, what's that? You're not wrong. You're not right.
So it was really quite conflicted because you wanted people to look at the board and I wanted like look.
Well, no. When I was only the important part, so there were at least 3 people that weren't looking at the board, so they're not going to get it if they don't look at the board. This is, believe it or not, this is an easy, hard part. The people that are paying attention get this like immediately, and the people that aren't, they're like, I don't even know what to do. And you're like, what? How is that possible? You know?
I have to re-explain it to Dan half the time during study hall because.
He doesn't pay attention.
And also.
He didn't get the midpoint thing, right?
He doesn't understand it.
I know.
I have to like re-explain.
Well, thank you for that.
Good eye. Good eye.